Hypothesis testing is like a detective story in the world of statistics. Imagine you have a claim or a hypothesis that a new drug is more effective than the existing one. You gather data, and now it's time to put that claim to the test. The first step is to establish a null hypothesis, which assumes no difference. Then you collect your evidence, like a detective gathering clues. Next, you calculate a test statistic, which helps you determine how far your data deviates from the null hypothesis. If that deviation is significant enough, you can reject the null hypothesis and support your alternative claim. But remember, it's not just about being right. It's about understanding the risks of type 1 and type 2 errors. A type 1 error is like falsely accusing someone, while a type 2 error is letting a guilty party go free. In real-world applications, from clinical trials to quality control in manufacturing, hypothesis testing helps us make informed decisions based on data, ensuring we don't just guess, but rather, we know. Welcome back to Chandrasekhar Research Academy of Business Studies. In today's video, we'll be exploring an essential concept in statistics and research, hypothesis testing. Whether you're a student, researcher, or professional, hypothesis testing is a fundamental tool for making informed decisions based on data. In this session, we'll break down key concepts and explore practical applications to help new learners master the basics. Hypothesis testing is a statistical method used to make decisions or draw conclusions about a population based on sample data. It provides a structured way to test assumptions and evaluate whether observed results are due to chance or a significant effect. There are two main types of hypotheses involved in hypothesis testing. Null hypothesis, H0. This represents the default assumption or statement of no effect or no difference. For example, in a business setting, the null hypothesis might state the new marketing campaign does not improve sales. Alternative hypothesis, H1. This represents the opposite of the null hypothesis and is what the researcher aims to prove. In the same example, the alternative hypothesis might state the new marketing campaign improves sales. The goal of hypothesis testing is to evaluate evidence from sample data and decide whether to reject the null hypothesis in favor of the alternative hypothesis. In hypothesis testing, there are two possible types of errors to be aware of. Type 1 error, false positive. This occurs when we reject the null hypothesis, even though it is true. Example, concluding that the new marketing campaign improves sales when, in reality, it does not. The probability of making a type 1 error is represented by the significance level, denoted as alpha, A. Type 2 error, false negative. This occurs when we fail to reject the null hypothesis, even though it is false. Example, concluding that the new marketing campaign does not improve sales, when in reality, it does. The probability of making a type 2 error is denoted as beta, V. The process of hypothesis testing typically involves the following steps. Define the hypotheses. Set up the null and alternative hypotheses. Choose a significance level. A. Commonly used levels are 0.05 or 5%. Collect data and compute a test statistic. Analyze the sample data using statistical methods like t-tests or z-tests. Compare the test statistic to a critical value. Determine whether to reject or fail to reject the null hypothesis. Draw a conclusion. State the results in terms of the null hypothesis and their practical implications. Let's consider an example. A company introduces a new product and wants to test whether it improves customer satisfaction compared to the current product. Null hypothesis, H0. The new product does not improve customer satisfaction. Alternative hypothesis, H1. The new product improves customer satisfaction. Significance level, A, set at 5%. Data collection. Conduct a survey with a sample of customers using both products. Result, after analysis, if the test statistic falls into the rejection region, the company rejects the null hypothesis and concludes that the new product is more effective. In summary, hypothesis testing is a critical tool for making data-driven decisions. Understanding the roles of the null and alternative hypotheses, as well as the risks of type 1 and type 2 errors, is essential for drawing accurate conclusions. Whether you're in business, healthcare, or academia, mastering these basics will give you confidence in your analysis. Thank you for watching. Don't forget to like, share, and subscribe to Chandrasekhar Research Academy of Business Studies for more videos on statistics, research, and analytics. See you next time. That's it for today's lesson on hypothesis testing. I hope you now have a clear understanding of key concepts like null and alternative hypotheses, type 1 and type 2 errors, and how to apply these in real-world scenarios. Remember, hypothesis testing is a powerful tool that helps us make informed decisions backed by data. Mastering these concepts will take you a step closer to becoming proficient in statistics and analytics. If you found this video helpful, don't forget to give it a thumbs up and share it with your peers. Subscribe to Chandrasekhar Research Academy of Business Studies for more insightful lessons on statistics, business analytics, and research. Got any questions? Drop them in the comments below, and I'll be happy to answer. See you in the next video, and happy learning.